Okay, hiding and showing in SNAP pedagogy. Jens characterizes this talk as an argument in favor of showing users everything, but I think that's wrong. I think I'm not arguing one way or another about that. I'm just raising it as a question that needs discussion. So what's hiding and showing about? So here's my first example. The way televisions used to work back when they were analog, probably some of you remember analog televisions. There was a beam of electrons that started in the top left corner and swooped over to the top right corner, and then went down to the next row, oops, then across and down and across, okay? So rows were the main unit of pixels as opposed to columns. TV hardware doesn't work like that anymore, but it pretends to, because it has to go in some order, so it goes in that order. Oh, that's right, I forgot to tell you the important point, which is, therefore, their screen coordinates have 0, 0 in the top left corner. And X does what you'd expect, it grows left to right, but Y grows downward rather than upward. So another way to think about that is the entire screen is in the fourth quadrant of a graph. And furthermore, because rows are the most important thing, you write your coordinates as row column, which is to say Y, X, rather than the more usual XY. Okay, we do it differently. We do it the way they do it drawing graphs in algebra class. Our origin is in the center. Our coordinates are ordered X, Y, and we interpret positive Y as meaning upward. Why do we bother doing it this different way instead of just doing it the way everybody else does? So one small but important reason is that it means if you go to 0, 0, the origin, it's in the middle of the screen, which means it's a useful place to start drawing pictures. Whereas if you draw a picture in the corner, everything is a lot more complicated if you want it to stay on the screen. But also, X, Y ordering and positive meaning up fits with students' expectations. I use the word student here advisedly because for this reasoning, it's students that matter, and in particular algebra students who don't want to have to deal with two different coordinate systems at once. So now the question is, if we're going to invent our own coordinate system, shouldn't we also make the underlying hardware coordinate system available to our users by having a primitive, go to down from top left position, and actually this is wrong, it should say YX. But so shouldn't we have a block like this? And the answer is no, we shouldn't. I'm starting with a clear, unambiguous case. Nobody's going to disagree with me about this, not even Jens, right? We should hide the hardware details from the user. We can hide the details from the user because our coordinate system works. Meaning there aren't any embarrassing cases where the sprite goes exactly into a corner and the picture blows up or something. Everything works just as it should. So the user doesn't need to know that there's any coordinate system other than the one we give them. Hiding details from the user is a kind of abstraction. This line is maybe the key, one of the key lines in the talk. Abstraction, I think, is the central idea of computer science. Not everyone would agree with me about it being the central idea, but I think I get pretty strong agreement that it's one of the central ideas of computer science. And it says, our job is to allow users to think in the terms of the problem they're trying to solve, rather than about the weaknesses of computers. So this is an example of abstraction, and it's an example that's completely uncontroversial. Okay, input types and custom blocks. This is the second example. If you look at primitive blocks, there's a bazillion different kinds of inputs that have these little hints in the form of input slot shapes. So we have rectangular slot shapes, and we have oval slot shapes, we have hexagonal slot shapes, and then we have this list icon and the gray rings for procedures, and then there's two kinds of menus. If you have a menu in a white background slot, that means that items of the menu are suggestions that are, typically useful, but you can put anything you want. In this case, any number you want, because it's oval, in that slot instead of using the menu. So that's a suggested menu. And then there's an exclusive menu, like this block, where the input slot is the same color as the block, and that means you can't type into it. So your only choices are these four choices for this particular menu. Now, you can drop a reporter on top of this input. You can always do that in Snap. But if the reporter doesn't report one of these four words, you're not going to get a very interesting result. So that's, what do I have here? 1, 2, 3, 4, 5, 6, 7 types. And then there are various modifiers to a type. You can add a default input. So this usually says move 10 steps when you see it in the palette. That 10 is a default input. You can make an input variadic, which means it has those left and right arrowheads, which as of yesterday, I guess, are left and right arrowheads with a vertical ellipsis in between them. Vertical ellipsis is supposed to remind you of a list. So you can make your blocks have the possibility of multiple slots for the same input. You can also make it variadic infix, like the way plus and times work. That as you create more slots with the right arrow, you get plus signs in between them, or time signs in between them, or whatever. So that's an infix variadic input. You can make it an upvar, which I'm not going to talk about because I'm running behind already. You can make a text input multi-line so that you can type a carriage return into it. Or monospace multi-line, which is what you want to use for computer programs. So all of those things need to be doable in creating a custom block. So how are we going to make that work? do we show or hide all the input types? And our answer here, which I think, again, is going to be uncontroversial, nobody's going to disagree with me about this, our decision is to do both. We both show and hide them. Because experienced users want to be able to do all those things that I just talked about on the last slide. But that much complexity will completely scare away beginners, and they'll decide they can't make custom blocks at all. Okay, I'm going to leave out this big parenthesis thing. So if you're a beginner and you click on one of those plus signs in the block editor, that means you want to put an input in here, you see this dialog where you get to type the name of your input or some text that you want to be part of the title. You click whether it's an input name or title text, and you say okay. And that's all there is to it for making an input. And this works fine because you get an input of type any, which means you can put anything in it and it'll be happy. But that's the short form. When you're ready, you click the arrowhead. Let me show you that over here, next to title text input name, there's a right arrowhead. And if you click it, you get this dialog, which is the long form input dialog, which has radio buttons for all those different input types that we talked about and more. And it has optional things like a default value, variadic, multiple inputs. I'm not going to talk about upvars. And this, oops. Sorry, 5 minutes, okay. And this little widget here is for making menus. I'm not going to go into how you do that. The thing about this is none of it is the least bit discoverable. If you want to understand this, you sit down with the reference manual and you go through it carefully and you teach yourself what all the bells and whistles mean. Okay, so that's an example where we both show and hide depending on how experienced you are. Third example, higher order functions. It says here, higher order functions are easy. So here's the definition of map. Written in Snap. There's no JavaScript in here or anything. And for the most part, it's just a simple walk through a list, look at every item in the list. But there's this green oval surrounding the thing that's magic, which is the call block, which says, call this function and give it this input. And that lets us have map. And you know, there weren't any magic mumbo jumbo JavaScript things involved. It really is pretty simple and beautiful that you can do map in this much code. Oops. In Snap is a thing of beauty. How could we not want to show this to kids? Of course we do. And that's what we did do in the early days of BYOB. All of the higher order functions were in a library written in Snap. Anything that could be written in Snap, we wrote in Snap rather than making it a primitive. In order to make the point that even the built-in things of the language they're using can be written in this language that looks like it's for babies. But it really isn't. The trouble is, if you do write it this way, it's slow. That didn't used to matter before we started dealing with large amounts of data, like all the pixels in a costume, say. That's a lot of pixels. And if you're going to walk through them, you want it to be fast. So a few years back, version 7, was it? Anyway, we turned the higher order functions into super fast primitives. And that increases the range of problems we can solve, because things, can run fast, and that matters. But it's also a big pedagogic loss, because okay, I'm done, all right, because we don't have this to look at anymore. So we really want to have it both ways. And now I'm out of time, so I can't tell you about the controversial one, which is Parsons' problems, where since the beginning of time, teachers have wanted us to let them hide blocks in the palette, so they could present kids with a palette that only has 7 blocks in it or whatever, and then say, use these to make a such and such. And for a long, long time, we said no. We resolutely said we're not going to do that, because we believe in empowering kids, not disempowering kids. And so we don't want to give them something less than the power of Snap to work with. We got talked into it for reasons I don't have time to tell you. And what happened is everybody got super excited about this. So like the main feature of Snap is that you can hide blocks on the palette. This upsets me. And I think it needs talking about, and I'm sorry I've run out of time.